What do we have? We have future value, present value, annuity value. Now we have A. I want to find out what is the equivalent present value. So I will use P equal to A, P over A, 12% or 3 years. This is the one. The A is equal to 300,000. P over A, 12.3. P over A, 12.3 over here. This present value actually not the real present value. Okay, by definition, if we draw how to say cash flow, this is year 0, this is year 1, year 2, year 3. This is the present. This is the annuity. Annuity always start from year 1 until year end. Okay, what we are doing now, actually we shifted everything. Originally this one is 3, this one is 4, this one is 5. So the present value will be at year 2, which is here. So we will find out the P prime. I put P prime simply because this is not the real present value. From the view of the whole project, from 0 to 5, this one is not the real present value. Okay. If you wish, you can call it as assimilated present value if you wish. But one thing for sure is this value is not the real present value. Okay. So far so good. You can stop me anytime. You can stop me anytime. Because this part here is very important, because if you don't understand this part, the later part will be, how to say, a bit difficult. Okay. From this point of view, this is the present value. Okay. But from this point of view, this one is the future because it happens after it. After year 0, that one is the future. You get my point? If you get my point, please respond. I repeat, from this point of view, this value is the future value. So this one is basically F, the future value for this, from the point of view of this guy. Yes. Okay, yeah. Okay, let me erase. That's why I prefer, I don't prefer online, because online I don't have the whiteboard to conteng. Okay. Now don't mess up this part anymore. Now I want to consider only this part, the so-called present value. This is basically the future value for this guy. Okay. In this case, we want to find the real present value given F. So in this case, we will use P equal to P over F, 12% for how many years? 1, 2, 2 years. This is where this compound interest factor comes into play. This one. What is this? This is your P prime, or the future value. That's why we use this P of F, because F and F, arithmetically speaking, they cancel out. Okay, arithmetically speaking, they cancel out. Okay, so there we go. So now we have this term, plus another term here. So what next we need to do is just to, plug in the numbers. Now let's plug in all the numbers. But I do agree this question is a bit tricky. Okay. Uh, I don't mind if you take a bit of time to understand, because I do agree this question is a bit tricky. So if P1, the present value for project 1 is this value plus this value. So what we need to do is just plug in the numbers. So we have P over A 5% for a period of n is equal to 1 plus I to the power of n minus 1 over I into 1 plus I to the power of n. Okay, what is I? I is equal to 12%, so it become 1 plus 0.12 to the power of 2 square minus 1 over 0.12 in bracket 1 plus 0.12 to the power of 2. Okay, that is for the first term. Same goes for this one. We need to check P given A. So you can check what is P given A. P given A is this formula. So in this case, 1 plus 0, 1 plus 0.12 to the power of 2 minus 1. Hold on. Is it power of 2 or power of 3? Power of 3. Cube I, sorry, 0.12, 1 plus 0.12 cube. So calculate this value and you get this one. P given F. Okay, let me again clear out the slide. P given F. P given F. P given F. Yes, this one. So this is the formula. Okay, this is the formula. Okay, and finally you get 734.226 thousand. Okay, of course the unit is ringgit Malaysia. Okay, that's it. That's it for project number 1. For project number 1, we calculate everything. You get the present value of 734,226 ringgit. Okay, that is the present value for project number 1. So now this is the main deal. The main deal here is on project number 2, because we want to find out what is the value of C that makes these two projects equivalent in terms of present value. Okay, clear? Okay, for project number 2, yes, we are going to use the same approach. Okay, let me clear out this one. I'm going to use this exactly the same approach. I'm going to take this part. I'm going to calculate the present value. I'm going to, okay, that's step number 1. Step number 2. Step number 2, I'm going to take this annuity. I'm going to find out what is the present value. Okay. After I calculate the present value for this one, I will consider this one as future value. And from future value, I'm going to bring this one to the present. So we have the total present worth value of the project. Okay, are you ready? Okay. Let's start with step number 1. Let's start with step number 1. Step number 1 consists of taking these two cash flow. I'm going to bring these two cash flow and I'm going to calculate the present value. This cash flow represents annuity. We want to find out what is the P. So if you have any difficulty to find out which one of the 6 compound interest factor we need to use, then of course the common trick is what you need to find out, what do we have? We need to find out P. So P equal to, what do we have? A. Okay, what is compound interest factor? Consider it as a simple arithmetic problem. A over here, P over here. How many percent? Percent. How many years? 1, 2. 2 years. There you go. You have this P. Okay, and this is the formula. Okay, this is the formula. C, P over A, 12%, 2. This one, C, P over A, 12%, 2 years. Okay, this part over here, settle. Okay, again, after this, I will share the recording. You can rewatch the recording and stop anywhere necessary. So next one, step number 2, I'm going to handle this part. Okay, of course, we have the future value, we have the annuity, we have the present. Can we use the future value approach? In fact, yes. In fact, yes. Yes, yes. But since I don't use that approach, so leave it. So we have A. This is the value of A. We want to calculate the present value. The present value happens over here. It happens at year 3. Okay, it happens at year 3. So far, everyone can follow. Huh? Okay, it happens at year 3. So in this case, A and P, what is given, what is necessary to find? We want to find P. The given value is A, the annuity. So the compound interest factor that we need to use, A over here, at numerator, the denominator is the P. 12%. How many years? 1 year, 2 years. 2. So C times P over A, 12%, 2 years. This value is the present prime. Okay, view from these two guy. But from this guy, this value is actually the future. I repeat, this value over here is basically the future for this guy. Okay, to avoid any confusion, let me clear out this part. Let me clear out this part. This part, so I'm starting step number 2. This one, we want to find the present value, P prime. The P prime, so we want to find P prime is equal to what is given, the A, the annuity, P over A, 12%, 2 years. So you have this part. So step number 3, I'm going to consider this value as the future value, and I wish to bring it here, the present. Future and present. What do you want to find out? The present value. Present value. What is given? The future value. What compound factor? F over here, P over here. What is interest rate? 12%. What is the value of period? Is 3, not 2. Because here we have 1, 2, 3. Is number 3, I want to bring it here. So 3. Don't confuse. Okay, don't confuse. So there you go. Multiply by this factor. Okay, I hope this one is clear. So next one, I realized that this value and this value are the same. So I want to put them in factor. So C times P given A 12% 2. This one 1 plus this one. 1 plus this term. So you have all the values you need. Next, the next step is to calculate numerically what is the value. So C, okay, this is 1. Where is it? Oh yeah, this one. This one. 1 plus I square, y square because number 2, minus 1 over 0.12 is the interest factor, multiplied by 1 plus I. So 1 plus 0.12 square. Y square again because of this number 2. Multiply by 1 plus P over F. P over F, if you still confused what is the formula, you can refer to this one. P over F. It's this value. 1 over 1 plus I. But this time, the number is 3. So you put cubic function, a cube. So, yeah, I think that's it. You just need to calculate this value and this value. You get 2.893 times C. So is it clear for everyone? Okay. So 2.893C. So in this case, what I'm interested in, is you want to find out what is the value of C that makes these two equivalent in terms of present value. So we have present value for project 1, present value for project 2. So what we need to do next is this value, okay, this value is equivalent to this value. So this is very simple maths. We have C equal to 256.98 thousand ringgit. This is what this person, okay, this project manager need to achieve in order to have equivalent present worth value. So how is it? Is it clear for everyone? I'm not quite sure whether this one I give it as final exam or assignment. I guess it's assignment for last 2 years. Okay, is it clear for everyone? Okay, good. Okay, next example. I would like to give an example so that it becomes clear for everyone. Not much slides more. Okay. Next is example, I guess is example 3 or 4. I guess it's 3. Okay. We have this cash flow diagram. So you spend some money for equipment. You spend around 5,000 ringgit. The lifespan is around 5 years, and the interest factor is around 8%. So from this machine, you want to make sure that the machine is profitable. Okay. How to make sure that the machine is profitable? So from this machine, we need to make sure that we have a minimum profit over 5 years. So what do we have? We have the P, the present value, 5,000 ringgit. We want to find out what is the annuity, what is the minimum profit that you need to make in order to make this machine profitable over 5 years. A, we don't know. Okay. Now coming back to basics, what do we know? What do we want to find out? We want to find out A, so you put A equal to, what do we know? We know P. What compound interest factor? P as numerator, A as denominator. What is the interest rate? 8%. What is the last span of the machine? 5 years. So we proceed. So yeah, A over P. So if you refer to the previous slide, A over P, hold on, A over P, yeah, this one. This is the formula. So what I'm going to do, I'm just simply copy this formula and paste it over here. So P is equal to 5,000. I is equal to 8%, which is 0.08. 1 plus I, 1 plus 0.08. What is the lifespan of the machine? 5 years to the power of 5 over 1 plus 0.08 power of 5 minus 1. So yeah, that's it. So we have this calculation and we get 1,252.28 ringgit. So it means that if you want to make sure that uh, the buying of the machine at least have what we call that a break-even value, you need to make sure that every year you need to get at least 1,252 ringgit 28 cents. Okay, if you make every year less than this amount, meaning that it's not even break even. So the purchase of this machine is how to say, a lose situation, not a winning situation. So that's why actually the engineering economics is quite important, because before you how to say, you purchase any material, you need to know, okay, what is the lifespan, and from that simple analysis, you need to make sure that the profit is above this value. Otherwise, it's not profitable. Is it clear? Okay, I hope that is clear. Bak kata orang Melayu, if senyap tanda setuju. Yeah. Okay. You want to take 5 minute break before we continue with other examples? Okay, 5 minute break. Huh? Okay, let's continue. Let's move on to example number 4 or 5. I lost track of the numbers already. So I guess this one is example number 5. Huh? Okay. Again, engineering economics is about making decision which project will have the less cost and give us profit. Okay, that is principle number 3. Even though we have marginal profit, the marginal profit must overcome the marginal cost. Okay, that is principle number 3. Principle number 4, we don't take any risk if the risk doesn't bring any benefit or profit. Okay, we rely on these two principles for this example. Huh? Okay, now we have two projects, project A, project B. Project A, you need to spend the first cost of around 650,000 ringgit. So this one ringgit. Huh? Every year, you need to spend around 5,000 ringgit for operation and maintenance, the OM. This one will be the cost. But for project A, every 15 years, there's no maintenance. Okay? Annually, we just spend around 5,000 ringgit annually. But after 15 years, after 30 years, after 45 years, we don't need to spend extra money for maintenance. For project B, the first cost would be 230,000 ringgit. Every year, we need to spend 13.5 thousand ringgit for operation and maintenance. But every 15 years, we need to spend 90,000 ringgit for maintenance. Okay. And for this case, I'm going to consider that the lifespan is infinite. Okay, over 100 years, over 200 years, it still continues. The project still continues. Okay. The interest rate is 8%. Okay, interest rate is 8%. So in this case, you as a project manager, you need to find out whether you want to conduct project A or project B. From your opinion, okay, let's say you don't have any basic knowledge about engineering economics. You give a wild guess. Which one of this project you will go about? Is it project A or project B? Anyone to give to wish to give a wild guess? If you give wrong answers, I will not deduct your marks. Don't worry. Anyone? Just A or B. That's it. Anyone? A or B? No one there to take any action? Any decision? Oh, in this case, we cannot be project manager lah. Anyone? We have around 60 plus students. No one there to take any decision. Come on, come on.
A, sir?
A?
Yes, assume infinite lifespan.
Okay. Amisha A. And then
A.
okay, Harold A. Anyone want to give a guess? Okay, one thing for sure, Harold 77967. A also. Okay, Harold, Amisha, and Mifzal, I don't want to hire you as my project manager. Definitely, I'm not going to hire you as my project manager. Because the answer is just in front of your eyes. Select project B, less cost. Okay, but it's okay. At least you have made a decision. Uh, there is also one uh, important skill set as a project manager. You dare to take decision. Okay, that's good. Okay, you choose project A because there's no maintenance. Okay, there's no maintenance. But look at this number. This number is way too high compared to this value. Okay, but that doesn't give any basis on how to choose the project. Okay, doesn't give any basis on how to choose the project. That's why it's important for you to have the knowledge of engineering economics, especially if you want to become a project manager. Okay, where your post require you to do this analysis and select one of these two projects. Okay, let's do the analysis. I don't think we have time to, we finish this example and then we can call it a day lah. Okay, for this case, actually is a bit different because we are going to assume infinite lifetime. The n is equal to infinity. The n is equal to infinity. Okay, let's start with project A. So a good way to evaluate any project is to calculate the present value. You have two approaches. Approach number one is present value. Approach number two is annual value. Okay, but most of the time, as project manager, you will go for the present value. Okay, you can if you have several projects, you would see which of this project will give you the best present value. Okay, so in this case, we calculate the present value. Okay, why don't we draw the, how to say, draw the, ya Allah, the cash flow diagram. Cash flow diagram looks like this. First cost, we need to spend 650,000. Every year, you need to spend, okay, this one until infinite. You need to, oops, what happened? Oh, okay. You need to spend, yeah, hold on. Okay, hold on. Let me escape. Okay, let me start. Okay, this is the cash flow diagram until infinity. Yeah, the first cost, when you want, if you want to start the project, you need to spend around 650,000 ringgit, and then every year you need to spend additional 5,000 ringgit. So I draw everything downwards because the first cost is a spending. The annual operation is also considered as spending. So I draw everything as how to say, uh, outflow cash outflow. So here, the present value, first we have this present value. So you have FCA, 650,000 ringgit. That's the present value for sure because that is the amount of money that you spend at time t equal to 0. And then what do we have? We have the annuity. Annuity equal to 5K. We have annuity. We want to find out the present value. So P, so the compound interest factor would be A, so P, 8%, infinite. Wow, this one beyond our our knowledge, infinite. So how can we do this? How can we do this? Okay, in this case, you need to go back to CANF 1013 where you learn about limits. Okay, first of all, I would like to have the P given A. Let me copy P given A. So P given A is this one. I Z. Copy. Where is it? Oh, here. I need to redraw the 650K. And then continually from year 1 until year infinity. 5K, 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 and so on until here. 5K. Okay. I want to copy the formula. Okay, this is the formula. P given A. Perhaps I can shrink the font. We want to find out what is the limit. Limit when n tend to infinity. What is the limit? So this is also equal to limit when n tend to infinity of this term. Okay, let's start with this term here first. Limit when n tend to infinity of the term 1 plus I of n minus 1. Or you know what, I'm not going to use this notation because otherwise it will be more and more confusing. Okay, sorry guys. I will use different notation. I want to take this part. Sorry. I want to take this part, the numerator part. The numerator part, 1 plus I to the power of n minus 1. When you tend the n towards infinity, this whole term is almost equivalent to 1 plus I to the power of n. Okay, everyone get my point or not? This term, when you tend n towards infinity, this term approach this term. Why? Because 1 is comparatively negligible in front of this value. So 1 plus I to the power of n minus 1, if we draw the 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 the, the curve, hold on, this is also not good, not a good approach. Okay, one good approach is, let's say you give n equal to 100, I equal to 2% or 0.02. Okay, please calculate this value and this value. Can anyone take out a calculator and calculate this value? This one is equivalent to what? This one is equivalent to what? Because I don't have my calculator in my office. Can someone calculate? No. Can someone please someone calculate? 6.24, first one. The second one. 7.24. Okay. Let's try different number. Let's try different number. Because this number is not practical. Let's try different number. Let's say the I is equivalent to 12%. 12%. Okay, the faster you calculate, the faster we finish this question, the faster we can go back home. Okay, 83522.25. Second one. 83523.25. Supposedly, supposedly, because just minus one. Okay, from this example, you can see that whenever we tend n towards infinity, these values almost the same. So this number one actually become negligible. So we can neglect this one. Can neglect. So this term over here can be approximated to 1 plus I to power of n. Okay. So this one, I don't put equal, I put almost equal to 1 plus I of n over I into 1 plus I of n to power of n. As you can see, this term and this term can be simplified. So meaning that the limit when n tend to infinity of this compound interest factor p over a I% infinity is equal to 1 over I. Okay, 1 over I. So in this case, we have AB over I. Sorry, AA over I. This is project A. Annuity for project A over I. So in this case, we calculate 650,000 or 650,000 plus the annuity, which is equal to 5,000, divided by the interest factor 0.08, we get 712.5 thousand ringgit. That is project number, project A. Okay, that is project A. Okay, let me erase, and we will proceed with project B. Okay, we proceed with project B. For project B, the same way I'm going to draw the cash flow diagram. Cash flow diagram, here is the first cost, 230,000. And then continuously, we will spend 13,000 ringgit, 13,500 ringgit for the operation and maintenance. But for every 15 years, year 15, year 30, year 45, and so on, every 15 years, we need to spend additional 90,000 ringgit. Okay. Okay, let's calculate the present worst value for project B. For project B, initially you already spent 230,000. So 230,000 already appear here. Annuity, so we calculate this one already. So this one can be approximated to 1 over I when n tend to infinity. So we have AB over I. AB over I. So we have this value. Okay, this one settle, this one settle. Let's settle out this one. So how can we settle this one? Okay. Again, this one, I concur. This one also quite tricky. Not a bit tricky, but a lot of trick. Because here, this one happens every 15 years. Okay, every 15 years. So what I'm going to do is, I'm going to separate this 90,000 ringgit into annuities. I will create annuities. So we want to find out annuity given the future value. So in this case, every 15 years, that is the future value. Okay, that is the future value. So this one would be A over F 8% for 15 years. Okay. So I'm going to get this thing, the annuity. This annuity actually is repeated continuously, infinitely. Yeah? So we know that the concept is whenever it becomes infinite, we need to divide by I. So we have F 90,000, A over F 8% for 15 years divided by 0.08. So in this case, we can proceed with the calculation and we get present worth value for project B 440,183 ringgit 24 cents. The present value A 712,500. Present value B 440,183.24. So which one of this value is higher? Come on, simple question. Which one of this value is higher? Guys, come on. The highest value is project A. But if you look at this question, this number is basically representing the cost. This one also represents the cost. So if you want to have a good business, you want to find out project which incur less cost. So in this case, less cost is project B. So you go for project B. Okay. So any questions? So the time already 5:30. Okay, I leave it this one for next week's discussion. So I have a few more slides. I think 4 more slides. 1, 2, 3, 4 more slides. Okay, 4 more slides next week. So we are going to spend a few, maybe less than 1 hour. So I'm going to redo this one. Okay, I believe many people, many students are not very clear on this part. Okay, never mind. I'm going to retake this example next week, and I'm going to continue with some more examples. And that will be the end for this topic. Any questions? Oh, dah layu dah semua. Okay. So I think that's it for this week. Okay. Again, sorry for the for the arrangement lah. I really have something this morning, so I unfortunately we need to read online lah. Okay. So if there's no more questions, I think we can just stop here. Stop.